So hi everyone. Today we are going to solve one question from Leetcode. Uh, it is this maximum points that you can obtain from cards, but we won't solve it. We will go through the discussion and understand the solution and do some dry run on it so that we understand how other people they approach the problems and we can learn from the solution of other people. So, Saurabh, let's first discuss the problem. Then we'll go to
Yes.
the discussion and see some solution. Okay.
So your screen is not visible.
1 second. Yes. So this question, Saurabh also solved it. So Saurabh, can you explain your approach? And first go through the question and explain the question, and then go through the solution that you have made.
Okay. So in this problem, we are given an array called the card points, and we have to pick k number of cards from either its front side or its back side, such that the sum of the points is maximum. So suppose we are having our array as this one. So if this is our array, then we have to choose 3 cards. So the first card will be picked from either its front side or its back side. So as both of them are 1, so we have to pick either one of them, which makes, suppose I have taken it from the back side, right? So that modifies our array to this. Now we have to pick our second card, and we will check which one is greater. Like if 6, we will choose 6, which will give us a better output, and at the last we will choose 5. So that's the basic problem. We have to choose either from its front side or its back side. So what I did was I used dynamic programming, and it's called the prefix sum method, like where we calculate the cumulative sum for each index and store it in an array, and later we use it in a loop such that we can get our output. Okay. So what I did was, like, this is our given array, right? And k value is 3. So at max, we either choose the first 3, the leftmost 3 cards, or the rightmost 3 cards. Okay, so here I will make one array called left, and for the safekeeping, I'm just putting a 0 at its index 0, because if we do not choose any card from left, then our cumulative sum will be 0, right?
Okay, yeah.
And if we choose the first card from the left side, then its value will be 1. And if we choose the second card, we have to choose both the cards, right? Because we cannot take one card out from the middle. Yes. So we will take both these cards, which will make our value to 3. Yes. And after that, as k is 3, we will go to this point, and this will give us a value of 6.
Yes.
So this is our left array.
Yes.
And for the right array, we will do the same process. Like for the 0th index, we will input a 0 because we won't choose any card from the right side. And then we will choose the first card from the right side, which will give us 1. Then we can choose the second card, which will give us 1 plus 6, 7. And the third card, which will be plus 5 to this 7. So which will give us 12.
Yeah.
So,
and we don't need to exceed like k equal to 3, because we only need up to k equal to 3. Yes. The length of this left and right array, they won't exceed k equal like 3, because we can only pick up to 3 cards. Okay.
Yes. So what are the possibilities for picking 3 cards? Like we can take 0 cards from the left and 3 cards from the right. We can pick 1 card from the left and 2 cards from the right.
Right, yes.
And we get 2 cards from the left and 1 card from the right.
Also, you can
And
pick
we can pick 3 cards from the left and 0 cards from the right.
Right, yes.
So, okay. So we will go to this index, the left of 0 index, which will give us 0, and the third index of the right, which will give us 12. So this gives us 12, and this will give us left of 1 is 1, and right of 2 is 7, which will give us 8.
8, okay.
And left of 2 is 3, and right of 1 is 1. So this will give us this. And if we choose the 3 elements from the left side, this will give us 6. So 12 is our answer. So here we can see the code like for us because we can either choose 0 cards, 0 to k cards. So I have made 2 arrays left and right with k plus 1 as its size. And answer is our answer variable, and I have initialized the 0th index as 0 because that means we won't choose any card from that side.
Yes.
And this is the first element because it is easier for these loops to begin if I fix these elements. So this counts the cumulative sum for the left indexes, and this counts the cumulative sum for the right indexes.
Yes.
And at last, we compare this, the answer, and just like here, the ith index of the left and the k minus ith index of the right.
Right, yes.
So this will give us our answer. And if I submit it, like...
yeah. So now like we have changed the code into, yes, you just have to comment it out. Yes. Like now the code is like very simple. We have a like left sum and right sum, and we just need to like get k k from either like left and right sum. So that's the modified version of the problem, which is easy to solve. Yeah. The important thing is here to go understand that which pattern of Leetcode you can use it to solve it. Like here it is possible to solve it using prefix sum. Like you can also solve it using backtracking, using like DP with top down, but that won't be very optimized, right? We have also discussed one solution how to solve it using top down. So we'll also discuss this problem. So now we solve the same problem using top down like DP with some caching, but
are you sharing your screen?
1 second. What we'll do is we will solve this problem using top down DP, but it will give you the correct solution, but it will time out because it will have n into k time complexity. So what we do is we take two index I and j, and k is the number of card, and this will give us for array I to j and for k cards, what is the answer? What is the answer? And we save it, in the dictionary. And so when we get, because this is a problem where we get this ijk again and again, so that we don't compute it again and again, and we just use it the next time we have it. So by doing this, we decrease the time complexity from exponential time complexity to like a polynomial time complexity, but it's still n square into k, because ij can go to n and k card, but it will give us a timeout, but it will still work. Like if you run the code, you will see that it's accepted, and if you submit it, you will get time limit exceeded. So this is a correct solution, but we have to, it is not optimized as the prefix sum solution. So Saurabh, do you want to explain this, how we solved it using this one?
Okay. So here the to calculate array of I to j.
So I'll explain. So we have the base case. If k is less than 1, then we just return 0. And if ijk is found in the dictionary, then you return the pre-computed value. Or if I is less than 0, which cannot be possible because this is array I to j, we return 0. And now we see if I equal to j, I mean you have only one element in the array, then and if k equal to 1, then it means that you have to pick that element. So you just initialize in dictionary ijk with that value and return that. Or if there is only one element and k is more than 1, it means that you have to pick two elements, but you have only one element in the array. In this case, we return 0. Now we have the main case. So we can either pick from left. In this case, the answer will be calculate I plus 1 to j k minus 1, and because we pick the left element, we put it in the sum, or we can pick the rightmost element I, j minus 1 and k minus 1, because we have picked one card already, and we add array of j, the rightmost element, and we save it in a variable in this dictionary, and we return this ijk in the answer, and the answer is calculate 0 to arrow length and k, and we got the answer. But of course, like, this is a correct solution, but this is not optimized, and this two-sum solution that Saurabh discussed is will pass all the test case, and that is more optimized for sure.